So friends, today we are going to study mole concept. Yes, the most difficult concept and most of the numericals of the 9th class covering this mole concept. Okay, so let us first understand what is this concept actually. Now for this you have to see, I am giving one example, you have to relate it with the reality. Okay, so first you think of 1 dozen. What does it means? 1 dozen means 12. 1 dozen means 12. 12 of anything. Okay, if you take one apple, 1 dozen apple means 12 apples. 1 dozen watermelon means 12 watermelons. Okay, so if we will see that 1 dozen apple is equal to 1 dozen watermelon. So that means 1 dozen means 12 apple and this 12 watermelons. So here you can see that this 12, the numerical value is almost same. Taking this, you can see we have taken the different objects, okay, but the numerical value is same. 1 dozen means 12. Okay, similarly for 1 mole, if you say like 1 dozen, the mole means 1 mole means 6.022 into 10 to the power 23 particles, ions, or molecules or atoms. So 1 mole, likewise 1 dozen means 12, 1 mole means 6.022 into 10 to the power 23 particle, ions or molecules. And taking any substance, 1 mole of any substance, that means 6.022 into 10 to the power 23 of that substance in numerical value. Suppose if I am taking 1 mole of apple, so 1 mole of apple here means 1 mole of apple means having 6.022 into 10 to the power 23 apples. Okay, similarly 1 mole of watermelon. 1 mole of watermelon means that 6.022 into 10 to the power 23 watermelons. Okay, so that means you can see that the numerical value is almost same, although we are taking the different substances, but the numerical value is same. So now the next we will see that although we have taken the different substances and different substances having the different weights. Okay, apple is having different weights, although 12 in number, 12 apple, 12 watermelon, but the weight of 12 apple and 12 watermelon will be totally different. If you will compare the weight of 12 apples and weight of 12 watermelons, there will be a large difference between that. Okay, so similarly for 1 mole also you will say that the particles will be different. Their number will be same, but the weight will be different. Suppose I am taking one equation. If you will see the simplest equation I am taking, you can take NaOH plus HCl. This gives NaCl plus H2O. Okay, so see, this is a very simple equation you can see. Now here in this equation 1 mole of NaOH is there, 1 mole of HCl is there, 1 mole of NaCl is there, and 1 mole of H2O is there, or H2O is there. Okay, so 1 mole of each and every substance we have taken. Now see, if calculating the molecular weight of NaOH, we find that the mass molecular weight of, suppose we are doing roughly here NaOH, so molecular weight of NaOH, it is 123, it is 16, and it is 1, so it is around coming 40 grams. Okay, so 1 mole of NaOH weighs 40 grams. Similarly, if we will measure the weight of HCl, so it is 35.5 for Cl for 1 and 1 for H, so it becomes 36.5 grams. Okay, now if you are not taking grams, if we are taking the molecular mass, we will be writing it as U. Okay, and afterwards we can convert it into grams. Now 1 mole of NaCl, 35.5 plus 23, it is 56.5. Now this 18 new. So now convert it in, this is the actually the molecular weights of this particular substance. So we can see, although all the different compounds, they are having the different weights, but we have taken the although different substances have different molecular weights, but all belongs to 1 mole. Okay, having 1 mole value of each and having 40. So now see, this is only the mole concept. Having different substances, different molecular weights, but we have taken the quantity as 1 mole. Okay, so this is the main mole concept.